This next lesson is about naming and classifying angles and also defining what an angle is. In order to define angles, we need the definition of a ray. A ray is a part of a line segment with one endpoint and all the points to one side of it. So a diagram of a ray would be like here's an endpoint, let's call that B, and then all the points to one side of that. Usually we need another point on the line in order to name it. The one that I just drew, if I were going to name it, would be called BA with an arrow on top with only one pointer on the arrow. Notice how I started with B? That's because B is the end point of the ray. So B is the end point in our diagram, so then in our name, B had to be the end point. If I had another point on our diagram, like let's say this was X, I could also name this ray BX, but I have to start with B because that's the end point. I would like to point out in the non-examples category that this picture up here is not AB because we have to start with the endpoint when we're naming it. So when we're naming it, we start with the endpoint, then we can say any other point on the ray, and then we put an arrow on top. The other thing I want to point out is that this is like a line, except it goes on forever in only one direction. This is a line, that's not a ray. And then it's not a segment because that has two endpoints. So we want our ray to only have one endpoint. Two rays that have a common endpoint form an angle. I'm going to draw a picture of an angle. So an angle would look like, here's one ray. Let's call that A, B. And then if I draw another ray with the same endpoint, let's call that C, that makes an angle. The shared endpoint is called the vertex of the angle, and I think of it as the elbow. So how big an angle is not how long the rays are, because the rays actually go on forever. It's how open the angle is from the vertex. So you can also think of the vertex as like a hinge or an elbow. If I want to make a bigger angle, I will open that more. When we name an angle, we use 3 letters and we use the angle symbol. So this is the angle symbol. And then we use 3 letters, and it matters what order our letters go in. The vertex has to go in the middle, and then the other 2 letters can go in either order. So I could call this BAC, and notice how if I had a highlighter, I could trace BAC, and that would form that angle. I could also call this angle, as long as the A is in the middle, I could call this angle CAB. If I do that, then I'm just tracing the angle in the other order, but it's still open the same amount, so it's still the same angle. It's just traced in the other order. Just a naming convention, this angle right here is not angle ABC because the vertex is not at B. The middle letter has to be the vertex when we're naming an angle. Okay, it's also not an angle if our 2 rays do not share an endpoint. That's not an angle. A tool for measuring angles is a protractor. A protractor is a tool that measures how open our angles are. So our first question, what is the vertex of ABC? Remember, the vertex is in the middle. So the vertex of ABC is B. That's the elbow or the hinge of that angle. What are the 2 rays that form angle DB? DBC. I'm going to go ahead and highlight that. DBC. The two rays that I see are BD and BC. Their common endpoint is B. That's the vertex of the angle. Okay, I'm going to go ahead and erase my highlighter for now. And then I'm going to highlight angle ABC. ABC. And it's asking me, what is this little M here? Stands for the measure. So the answer to these questions will always be a degree. What is the measure of angle ABC? So if I go ABC, I see two choices. It looks like this lands at 60 and it also lands at 120. And the way I decide which one to use is 90 would be straight up and down. Anything that's less open than 90, I'm going to use the smaller number. So ABC is 60 degrees. That's the smaller number. Okay, if I choose a different color of highlighter, I'm going to highlight DBC. So DBC, that's an angle, and it's at the same spot on the protractor, but at that angle is more open than straight up and down. So this one is going to be 120 degrees because that's the number that is bigger than 90. And then the last question, what is the measure of ABD? That angle goes all the way across. It is a straight angle, and the measure of that angle is 180 degrees. There are actually some classifications of angles that are useful to know. The first classification is an acute angle. An acute angle is an angle that measures between 0 and 90 degrees. It's not very open, it's cute because it's so closed up. A right angle is exactly 90 degrees. So as soon as we hit 90 degrees, that's called a right angle. This box symbol lets us know that a picture in our diagram is a right angle. It doesn't have to have the 90 degrees next to it. If we see that box symbol, we know that we are at 90 degrees. An obtuse angle is an angle that's bigger than 90 degrees, but it's less than 180 degrees. So it's going to be between 90 and 180 degrees. Our angle is not 90 because that would be a right angle. So it could be a little bit bigger than 90, but it's got to be less than 180. And then a straight angle is exactly 180 degrees. We know that a straight angle because it looks like a straight line. So if you see a straight angle, that means that the vertex is, or the joining point for the rays point in opposite directions, which makes 180 degrees. Okay, the other big concept for today is the angle addition postulate. And we're going to draw a picture for this postulate. So first, if point D is on the interior of angle ABC. So I see that the vertex is B. So I'm going to go ahead and make the vertex B. And then I'm going to make a ray that goes through A and another ray that goes through C. That is angle ABC. And then I'm going to draw point D somewhere on the interior of that angle, and then I'm going to draw the ray BD. What the postulate says is that the measure of angle ABD plus the measure of angle DBC is equal to the measure of ABC. I hope that looks familiar to you from our line segment addition postulate. This is the part and the part, and they add up to the whole. So this is another part plus part equals whole situation. If you have an angle that is cut by a ray, then you can add the two pieces together to get the whole. The two parts make a whole. Okay, that is the notes for this section. I will post my answers to the practice problems online.